So we're starting with a new concept, which is adjacent angles and vertically opposite angles. Now let's review few things that we discussed earlier about angles. So if this is an angle A, B, C, we said two semilines, they form when they meet two semilines. This is a semiline and this is the semiline. They intersect at one point, so they form an angle. Okay, so this is the angle. Now, what's the name of this angle? The name of this angle is angle ABC. So what do we have over here? We have, this is A, then we put point B, then we put point C, so the name of it is angle ABC. Now, this angle has a vertex. The vertex is B. How to find the vertex? So, where the two semilines intersect, this is the vertex. This is the vertex B. Now the sides. We have over here, we said we have two sides. This is the first side. This is AB. This is the second side. It's BC. Again, this is the angle. This is K, L, M. Again, we have two sides. We have this side, KL, and this side, LM. They meet at one point, which is the vertex, L. Again, what's the name of the angle? It's KLM. Again, how did I name it? So I put this is KLM. The vertex should always be in the middle. Then, again, this is the vertex L and the sides. What are the sides that we have? The two sides are ML, this is ML, and LK, this is LK. Now, adjacent angles. So, if we have this figure, this is A, B, C, D, and I told you angle ABD and DBC are adjacent angles. Again, if I told you angle ABD and DBC, they are adjacent angle. What do you mean by adjacent angle? Adjacent angles, it means they have a common side and a common vertex. So, this angle and this angle together, we call them adjacent angles. Why? Because they have a common side and they have a common vertex. So, what is the common side that we have over here? It's BD. This is the common side. Again, we are talking about this angle and this angle. Both of them are adjacent angles because they have the same side. They have a common side. What else do they have? They have a common vertex. What's the vertex over here? The vertex over here is B. So if we look at the names of the angles, ABD, which is this one, ABD, and DBC, DBC, we can find in the middle we have the same letter, which is B, which is the same vertex, and over here the side BD and DB, this is the same side, so that's why they are adjacent angles. Now, another example. If we have this figure, this is P, this is S, this is T, and this is U. Now, if I told you that PSU and UST are adjacent angles, again, adjacent angles means they are neighbor angles, they are neighbors. So this is angle PSU and this is angle UST. So this angle and this angle, they are what? They are adjacent angles. Why they are adjacent angles? Simply because we have a common side, which is US. This is the common side, as you can see, and they have a common vertex, which is S. Over here you can see this is the common vertex, which is S. Again, we are talking about this angle and this angle. Both of them are adjacent angles. Okay, so if we look at the name of the angles, you can see in the middle we have S and S. They have the same vertex. And if we look at the side SU and US, we have the common side. Again, now we're starting with something called vertically opposite angles. In vertically opposite angles, let's look at the following figure. If I told you that angles ABD and EBC are vertically opposite, so these are the angles ABD and EBC, so this angle and this angle, they are vertically opposite angles. They are opposite. Can you see? This is opposite to this. What do they have in common? They have this point in common. What is this point? This is the vertex. It's as if we have two letters of V at the opposite of each other. Okay? So, in vertically opposite angles, we have a common vertex, which is the B. And we have both angles are equal. What do you mean by both angles are equal? So, if this angle is 110 degrees, for example, this opposite angle should always be equal to 110 degrees. If this angle, for example, is 120 degrees, this opposite angle should be also 120 degrees. Now, the sides are the prolongation of one another. What do you mean by the sides are the prolongation of one another? So if this side of the angle is a prolongation of this side of the second angle, and this side of the first angle is a prolongation of the side of the second angle, as you can see. Again, angle ABD and EBC, both of them are vertically opposite angles. They have a common vertex. Both of them are equal, and the sides are prolongation of one another. Again, this is the figure. Now, if I told you ABE and DBC are vertically opposite, let's see the angles. We have angle ABE and DBC. They are vertically opposite angles. So this angle and this angle, they are vertically opposite. What do they have in common? They have B in common. It's as if two letters V at the opposite of each other. Okay? So, they have a common vertex, which is B, and they are equal. What do you mean by they are equal? So if this angle, for example, is 60 degrees, this opposite one to it is also 60 degrees. If this one, for example, is 50 degrees, this one opposite to it is also 50 degrees. So both angles are equal. What else? The sides are prolongation of one another. What do you mean by prolongation of one another? So this angle having this side is the prolongation. This is the prolongation of it. And this side of the angle having the prolongation of the other angle, which is BD. Okay? So when we have vertically opposite angles, both angles are always equal and having a common vertex